We have a graph again, so we'll do an Euler. Look at our origin, decreases down to 0. And here we have 0, even increments, so that is our origin. So we're looking at a quadrant 4 situation. Our vertical axis is force in normal units, x-axis in time. So therefore, any questions about force and time will be read off the graph. The gradient delta F over delta T is the rate of change in force. And the area is F delta T, which is the impulse, which is delta P, which is M delta V. So we're now told that there is a block of 10 kilograms, positive direction with with negligible friction. Its initial momentum is 18 kilogram meters per second, collides with an object of unknown mass that is at rest. The force exerted on the block as a function of time is shown on the graph. So this object is going to exert some force like this in a negative direction. And lo and behold, we can see that from the graph. It starts with a 0 force and it increases to a maximum force like so. Which of the following describes the speed and direction of the block immediately after the collision? Immediately after the collision. Well, what we're looking for here is probably the change in momentum. We want to know the speed afterward. So that is the area. Now, if we notice here, the maximum is 25, so the average force is 25. And we're looking for this area here like this, which is minus 25 by 0.5. And so that's going to be minus 12.5. So we know delta P is P minus P0. We want to know the final P. We want to know what's going afterwards. So P then is delta P plus P0. And the change in momentum we just figured out is minus 12.5. And the initial momentum is 18. So that gives us a final momentum of 5.5 kilogram meters per second. So if it had 18 kilogram meters per second and it has 5.5 afterward, it's the same object, same mass, its speed will have decreased. And the direction we can see is the same direction because it's still positive. So we're looking at choice